Welcome back everyone to another video in our FE Civil Preparation course. In this video, we are going to talk about soil consolidation. Consolidation is a phenomenon that is associated with saturated clay soil, and it is the process of soil volume reduction under pressure due to water seepage. As we can see here, if we have this layer of saturated clay soil, if we started to apply pressure on the soil, with time it will start to get compacted as the water escapes from the pressure due to the seepage, and this will create settlement to the structure above the soil. So it is important to learn how to calculate this settlement. If the soil pressure is reduced after the pressure is applied due to getting compacted and due to water seepage, this means that the void ratio in the soil is going to get reduced also. So if we have these two layers of soil, the soil initially had layer height of h, and after compaction, the soil layer height was reduced by the amount of delta h. If the soil void ratio initially was E naught and the reduction in the void ratio is delta E, this means that the final E will equal to E naught minus delta E. The relation between those variables are governed by the following equation: S ultimate over H equals to delta E over 1 plus E naught. If we took the term of delta E over 1 plus E naught and we called it epsilon V, this means that the S ultimate equals epsilon V multiplied by HS. And this is the equation here that we have in the FE handbook regarding this part. But you can see that the delta E is mentioned to be the total change in void ratio due to recompression and virgin compression. In our next slide, we will understand the meaning of virgin compression and recompression. Any soil layer might have existed for thousands of years, and through this time, it goes through multiple cycles of loading and unloading. The loading might be very minimum that it doesn't create consolidation to the soil, such as vehicles load, or it could be heavy loads such as buildings and towers loads. The initial effective stress that the soil will start to consolidate under is considered to be P naught. Now, let's take an example. If we have a land in the middle of the desert where no structures were ever built, so the soil were never under the stress that exceeds P naught, which let's assume it to be 20 kilopascal, and a developer decided to build a community of villas there. The stress on the soil due to those villas were found to be 50 kilopascal, for example, which means that it is more than P naught, with the value of delta P, where delta P equals 30 kilopascal. In that case, the soil will start to consolidate, and in this case, it will be called virgin compression, because this is the first time for the soil to experience a stress that exceeds the initial effective consolidation stress. Now, let's imagine that after many years, another developer buys the same plot and decides to demolish all of the villas to build a community of multiple towers. Once the new developer demolishes the old buildings, the earlier stress will be released from the soil, and the soil will start to slowly expand to gain a small part of the previous consolidation. After the towers are built, the stress due to these towers were found to be 100 kilopascal. So what is going to happen now? In this case, we have P naught equals to 20 kilopascal, and we have the past maximum stress on the soil equals 50 kilopascal, and we have the new load of 100 kilopascal. It makes sense that the soil in the range of stress between 20 and 50 kilopascal will experience consolidation again, but it will be with way lower rate than before, because the soil has already experienced that load before and started the consolidation process already. So that range will be called recompression range. While in the range between 50 and 100 kilopascal, the soil consolidation rate will be higher, because this is going to be the range of virgin compression, because the soil has never experienced a stress higher than 50 kilopascal before. Now that we understand the difference between virgin compression and recompression, it will make sense to study this curve and those equations which we will use to solve any consolidation problem in the exam. So, if we considered E naught as the initial void ratio and delta E as the change in void ratio, P naught as the initial effective consolidation stress, Pc is the past maximum stress on the soil, and delta P as the change in stress in the center of the soil strata. Now, if we check this graph, which is the relation between the pressure in log scale in the horizontal axis and the void ratio in the vertical axis, we can see here that the P node value is corresponding to the E node value, and the pressure keeps increasing till it reaches PC, which is the past maximum stress, and now this range is recompression range, and the slope of this range is called CR. After that, the pressure keeps increasing till it reaches P node plus delta P, and now this is the range of version compression, and the slope of this range is called CC. Now we can see clearly that the slope of the version compression CC is higher than the slope of the recompression CR, and the relation between compression index is shown here as CR equals to CC over 6, while version compression index could be calculated by the change in void ratio over delta log B, or by the equation of CC equals to 0.009 multiplied by liquid limit minus 10. There are three different cases to calculate the delta H. First case would be if the past maximum pressure is higher than both the initial pressure and also the final pressure. In this case, all of the range of pressure will be here, which is inside the zone of recompression, and the delta H value will be calculated from the following equation, which is delta H equals to H naught over 1 plus E naught multiplied by CR log P naught plus delta P over P naught. Second case would be if both initial and final pressure are higher than past maximum pressure. In this case, all of the range of pressure will be here, which is inside the zone of version compression, and the delta H will be calculated from the following equation, which is delta H equals H naught over 1 plus E naught multiplied by CC log P naught plus delta P over P naught. Third case would be if the initial pressure is less than the past maximum pressure and the final pressure is higher than past maximum pressure. In this case, the range of pressure will be here, which is divided between both recompression zone and version compression zone, and the delta H value will be calculated from the following equation, which is delta H equals H naught over 1 plus E naught multiplied by CR log PC over P naught plus CC log P naught plus delta P over PC. So now let's have an example on this. So let's check this example. We have a saturated, normally consolidated clay with water content of 30%, liquid limit of 40%, and plastic limit of 20%. The specific gravity of solids is 2.7, and we want to calculate the approximate compression index. First step, we want to know if this is a version compression or recompression, because we want to know the compression index. Is it going to be CC or CR? The key answer for this question here, it is saying normally consolidated clay. If it says normally consolidated, this means this is a version compression, not recompression. So CC, which is the compression index for version compression, equals 0.009 multiplied by liquid limit minus 10. This is very direct. It will be 0.009 multiplied by 44 minus 10, which will equal 0.27. So this is going to be our answer, which is number B. Let's check this problem. We have a saturated, normally consolidated clay with water content of 30, liquid limit of 40, and plastic limit of 20. The specific gravity of solids is 2.7. Vertical stress increases because a new construction, and it causes the effective stress on the clay to double. How much will be the void ratio of this clay? How much it is going to decrease the void ratio of this clay because of the new construction? First step, we want to identify if this is a version or recompression, and here it says normally consolidated, and as we learned, this is a version compression. So we will start by calculating CC, which is the compression index for version compression, and it equals delta E over delta log P. At the same time, we know that the CC equals 0.009 multiplied by liquid limit minus 10, which is 40 here, so the CC will equal 0.27. So this means that 0.27 equals delta E over delta log P. And we want to calculate the delta E here, because this is what he's asking for. He wants to know the change in the void ratio. So now we need to calculate the delta log P. And delta log P, it equals log P2 minus log P1. And we also know from mathematics that log P2 minus log P1, this equals log P2 over P1. And here it is mentioned in the problem that the effective stress on the clay was doubled because of the new construction. This means that P2 over P1 equals 2. So the delta log P will equal log 2. And you can easily calculate log 2 on the calculator, and it will equal 0.3. So this means that the CC, which is 0.27, equals delta E over delta log P, which is 0.3. So now you can easily calculate the delta E, which equals 0.27 multiplied by 0.3, which will equal 0.81. So this is going to be the answer, which is number B.